we're back. Hey, everybody. Thank you guys so much for joining us today on another episode of The Good Thing. I'm joined, as always, by my amazing co host, Jens. And today we're going to be talking about some cool things that happened over the past 2 weeks. Um, Apologies for not doing the last 2 weeks. I caught the flu, and then we also had our annual retreat, and we were up in Alta, Norway. So it's been a bit since we last chatted, Jens. But how are you? How are things? I mean, I talk to you all the time, but how are things going with you?
I'm good. What do you think of this shirt?
I think it's better than most of your shirts, but I do like the Pac-Man. It's a nice. Did your wife buy it for you?
I think so.
We have a funny joke here that Jens, he's like, I don't buy clothes. They just appear in my closet because my wife bought them for me.
Yeah.
But awesome, dude. Today I'm excited to chat, Jens. So we got some really exciting stuff. So I want to talk a little bit about the culture and the retreats that we do, and hopefully we can, I guess, encourage some amazing engineers to join us. But Jens, talk to us about the past week. What was your experience with Alta, Norway? What did you like about it? Tell us, maybe the audience, a little bit about what we did up there and just kind of what makes working at WunderGraph amazing.
It was so funny. So we had 3 batches of flights. So everybody came in 3 batches. I was in the last. Was it 2 or 3? 2, 3?
I don't know because I took 4 flights.
No,
it was
3.
but
First
3 batches.
Subich, Nithin, then you guys, and then Björn and I, yeah. Imagine. So you fly into an airport in the middle of nowhere. You're on the last flight. It's in the middle of the night. It's like 10 p.m. or something. You get your luggage. Imagine this airport. It's like there's one, what's it called? Where you pick up your luggage. This belt.
The baggage
the
claim?
luggage belt. Yeah, baggage claim. There's one little thing, and the room is like just this one thing. That's the airport. You take your luggage. You walk out, and then there comes like a bus with like weird lights, and some weirdos step out, and they have like 10 boxes of pizza. That's just the scene, and everything is like snowy and everything. And then we drive this bus to our lodge, and eventually the bus gets stuck because there was too much snow. So we all get out and we carry our luggage, and then we go into the lodge. We set up the fire and everything. Over the days we had like 2 events. One event was snow sledging with dogs, which was pretty awesome. I have never thought that dogs can be such amazing animals, like how much they can carry. Imagine, like I'm not the most light person, but yeah, and I was together in a group with Nithin, so I don't know, like probably 150 to 200 kilos, the sledge, and then 5 dogs in front of us, and they can pull it off like pretty decent. So dogs are very cool. Like it was like Alaskan Huskies, pretty dope animals. Then we had a workshop day that was pretty cool because everybody interacted in a really productive way in such a place. It was also awesome. And then third day we had this, what do you call it, like motor ski scooters, whatever.
Snowmobiling.
Yeah, snowmobile. And it was very interesting to explore the tundra there. Like everything is icy and whatnot. And great views. Overall, it's really cool that you can build a company that enables this kind of stuff. And so we're pretty happy of being able to do that, and that we have all the support from customers and others who allow us to not just build a product but also meet from time to time. You know, we're a remote only company, so we're happy.
I would add to that. I mean, one of the coolest things about WunderGraph is, so we are remote first. We set you up with some equipment wherever you work in the world. That's fine. We have very flexible PTO. But the most important thing is we have to meet in person at least twice a year, the whole team. Sometimes a little bit more often when we get new hires. We fly them out to Germany. We get this really cool place. We work together. We eat Frankfurt Schnitzel with the green sauce. And we collaborate together. The reason we do that is because there's a thing called Zoom fatigue. You know, like me and you are on Zoom, but there's no better collaboration than when we're in person or we do a customer call and you're right next to me. And one of the benefits of WunderGraph is we understand you have a family. We understand that you live where you live where you live, work on good work, and then come hang out in Alta, Norway, Mallorca, Austria, Amsterdam. We fly you out, all expenses paid for, and you hang out with the team. We do team building. And what I've noticed, and Jens, correct me on this, is every time we come back from the retreats, the energy level is just off the roof for the next 2-3 months until we meet again.
Yeah, I would agree. Also, I think every retreat it somehow helps us to sharpen what we think is WunderGraph, what we should focus on, all these kind of things. So you can kind of see the journey from the very beginning, pivot, and then over the last 2 retreats, I think it got really, really sharp, and now see where we are. Yeah. What would you say? What are your highlights from the recent retreat?
It's a good question. So for the audience, I actually the week before I had the flu and I was still recovering from it. So I know why Jens asked this question. But the medication caused me to have some stomach problems. So I was there, but I was struggling a little bit with health. I'm all good now though. But the biggest highlights for me is first of all, the transparency. As founders, we're really transparent with everyone that's on board with the company. So Jens always does a state of WunderGraph presentation where we talk about the ARR, we talk about any new things that are important in the company, we talk about the product direction, and we talk about everything fully transparent. Everybody knows what deals are in the pipeline. They know which potential customers we might get, and they know everything that's happening. And I think that's super useful because Jens, you give us a bird's eye view to everybody, whether you're an engineer, whether you're on the marketing team, whether you're on customer support. And I think that's important because it creates a sense of camaraderie as also a sense of belonging to the company, is that, hey, I'm not just an engineer and my code just isn't just for some random customers, it's for these customers and I can actually contribute for the company. And so I think that's one of the best highlights this year. One of the best highlights that we did is with our rapid growth, we acquired a lot of customers, and so we've had to on the fly build out customer support, and I'm quite proud of the team of how we've done it. But this year we did a customer success award ceremony where we gave out awards to rising stars, to customer support engineer of the year. And I think that was really exciting because the engineers got feedback on how they did on something that they've never done before. They really picked it up on the fly. And I would say our customer support is top tier. And so that was another highlight. And then the third highlight is just, I mean, just sitting around the fire, bantering, playing Mario Kart, and just chatting with the team is always a positive. But doing it in Norway, where you're surrounded by snow and a beautiful cabin, and you get to go to a nice dinner and really celebrate the last year's accomplishments, I would say those are my top 3 highlights.
Do you remember we had in the very end, we had like a kind of like a collaborative survey thing, where we collected like, well, what are our biggest strengths? Do you remember the one thing that everybody kind of mentioned?
I do, but I want you to say it.
So I think one thing that stood out, what most of our employees said, is they really like working in the company. And I was thinking a bit about like, why is that? Like, what did we do so that we kind of achieved that? Like we didn't really want to achieve that. It's more like a consequence of what we do and how we act. And I think it has a very close relationship with one thing that we hear from many engineers is that before they join us, they work on some sort of product, and typically the loop between some customer request and when they release it and when they get feedback, this loop, it can be weeks, it can be months, sometimes years, oftentimes actually never. And there's so often that engineers work in environments where they have like a disconnect between customer and engineering. And maybe you can speak a little bit about how it looks like inside WunderGraph.
Yeah, it's a great topic, and I think it's something that really differentiates us, especially as we continue to scale and get more customers. We want to stay as close as possible to the customers because I think the relationships we build are amazing. So the way we currently do it is per week we have a engineer that's on call, and this is our on-call engineer. And the priority is that if there's any customer issues that are segmented by whatever totem skill that we have, that they need to jump in and support that person. The goal is they first try to start on it. And then after that, if they need to escalate it, they escalate it. And I think that's super important. And when they're not on support, they're doing feature development. And what's really great about being a customer of WunderGraph is that you'll never talk to a non-technical person. And I want this to go on as we continue to scale and we continue to grow. But if you work on, for example, the router and you have an issue with the router, you have direct access to the router team. And what's great is when they push an update or push a change, they are directly encouraged. We encourage our engineers to work on their soft skills and to talk to our customers. And so they'll tell, I don't know, one of our customers, SoundCloud, hey guys, we pushed a update to the router. This was what you guys reported last week. Here are the updated changes. Please test it out and let us know. And I think that feedback loop of actually allowing our engineers to talk with the customer, it creates this, I don't know what the word is, but you can tell that our engineers like working at WunderGraph because they're actually able to see their contributions and how it affects the companies. And they are able to get that feedback away. And the shorter the feedback loop, the happier they are. What do you think on that, Jens?
Yeah, by the way, don't touch your microphone. But should I do it? Like, you're doing this all the time.
I think it was my jacket hitting it. Is it better now?
Yeah. No, it's fine. Yeah, I think it's really this close feedback loop, and it's very, very rare that you're working on something that there's no customer waiting. So typically there's always like immediate demand, like the market is pulling, and yeah, we can't catch up. That's why we're hiring people. And it's really important what you're working on. We try to slice it in small portions, release fast. And also another big topic, reliability, because you cannot be fast if you're not reliable. One of our biggest topics is you can, for example, take a look at our test suite. It's growing so fast, and just recently we heavily invested into making our tests much faster. We have an end-to-end test suite, and for example, one thing we had like testing cycle of 2 minutes to run a test. Not so bad, but for us it was too slow. We've now cut it down to 10 seconds to run our complete end-to-end test suite, and it's just ever growing, because for us, on the one hand side, we want to move like super fast, but with so many customers who rely on the correctness of our solution, it's paramount that we really focus on releasing something that absolutely works. And yeah, so there's a thin line between speed and reliability, and yeah, I think at this point in time we're walking right in the middle of the street.
I would agree. And a quick point there, Jens, what do you see in the next couple of months? What key hires are we looking for? So I understand on the marketing side, we're looking for a vice president of marketing, but on the engineering side, what are we looking for? What roles and how can people apply and come join this amazing company?
Yeah, it's actually pretty simple. If you look at our code base, we have Cosmo. Cosmo is full stack Node.js TypeScript. In the front end, we have React. In the back end, Node.js, like Postgres, database, Redis, these standard boring things. And then on the router side, our router is written in Go, and our query planning engine and everything around that, it's also written in Go. So there's two very simple opportunities. You can come in as an engineer focusing on Go, or you can be a full stack engineer. Go engineer means you build router, you work on things like telemetry, you can work on the query planner. There's like kind of like we have two disciplines. We somehow were mentally split the router into two parts. One part is more like a gateway, and the second part is what we call the engine, which actually is a second repository. And in the engine, it's about query planning and query execution. And that's kind of algorithmic, like data structures, graph traversal, AST rewrites, all these kind of things. I very much like it. It's interesting stuff. And then you have the gateway side, telemetry, analytics, metrics, like all things gateway, what you would expect from an API gateway. Yeah, and then in Cosmo, Cosmo is the brain of the whole thing. It understands like feature flags and your graphs and composition and everything that belongs there. And yeah, you have a mishmash of some functionality in the backend, then some React and Tailwind in the front end. We want to show the functionality. We built diagrams to expose the metrics and everything. So these are the main opportunities, I would say. And then inside these two categories, you can also have like two focus points. So you can have a focus point like you go very deep on the product end, or you go a little bit less on the product side and you go more customer facing, because there's always like kind of like we have a long-term vision where we want to drive the product, and we have like short-term goals where we want to enable customers. And you can be more in the on the side of customer enablement, something like, oh yeah, we need a custom middleware here, we need like customization for metrics, or I don't know, the multi-path protocol is not exactly implemented like some spec says, or whatever, these kind of things. And then you have like deep long-term efforts where we say, okay, this is where we want to be in 1 year, and this is a bit different scope of tasks.
Yeah, well said. And if I was an engineer and I wanted to work at WunderGraph, how would I catch your eye? Because we see every application that comes in. How would I catch your eye, Jens, where you were like, we need to interview this person?
So, you know, there's this mythical 10x engineer, and we are not so big fans of the 10x engineer. We are big fans of someone who is good enough in terms of tech to do what needs to be done, but they are an excellent team player and communicator. We're a remote company. If you work together with people for a long time and you want to achieve a goal together, you don't need so many sprinters. You need marathon runners who can actually work together as a team. Because if you run a marathon as a team, someone needs to be in front, block the wind, and then everybody can follow on like a little bit less power mode. And then you need to circle around. And for us, it's a team effort, but still you need to run fast enough. So there's like a threshold. You need to be good enough, and that's one part. But don't be afraid of joining as a junior. We absolutely love juniors with the right attitude, because we believe it's actually harder to hire seniors. Seniors often they are opinionated, they have habits. These can be good, and it's also possible that they are incompatible with how we think. Versus juniors, their opinion often it is not yet so strong, so you can mold them a little bit more. So actually we like both. Like for seniors, we need to see, are they compatible with us? And it's okay if not, like everybody's different, that's fine. And for juniors, we're also very open. So please, if you are a junior dev and you're ambitious and you're super interested in learning and expanding, we hired a bunch of juniors like 2 years ago, and it's absolutely crazy what they have achieved in 2 years. So yeah.
Yeah, well said. And I think it's a good transition. So as Jens mentioned, we're hiring. You can see we've posted more jobs and they're going to keep posting. So keep a lookout on our jobs tab. But I want to transition because we have a lot of topics to discuss today. Let's talk a little bit about what happened on the retreat. So Jens, aside, you're not able to mention the company name due to an NDA, but we are working on a feature, pre-warming cache. Can you kind of tell us like a high level overview of it and why it's important? And then we can talk a little bit about the reason it's important. A little hint, it's for a very major event that's coming up in February, and we also want to talk a little bit about those preparations. But talk to me a little bit about the pre-warming cache. What exactly is it, and why did we build it?
I can say the event, right?
Yeah, you could say the event, but you cannot, under any circumstances, mention the name of the customer.
Yeah.
Please,
Okay.
we're live. Don't do that.
So imagine you're a company and it uses Federation, and you run an ad on the SuperBowl. So you might get a little spike in the traffic, which means I don't know much about SuperBowl. I guess it's kind of big. I don't know how big, but okay. So let's say
I'm clipping that, by the way, and for our American audience, I love it.
So let's say you get a little spike in your traffic. That means you need to scale up your routers. Okay, let's say you quickly scale up routers to satisfy the demand. What happens if a query hits a router and it takes 10 seconds to plan the query? So
non-technical question for the non-technical folks, since this is on LinkedIn.
Like you.
Basically, yes. What do you mean by like a query? Like what's happening? Like they hit this website and they send a request in the query, in the GraphQL query. Can you explain that a little bit?
Okay, so you click on the ad, you go to a website. The website wants to show you some content. Okay, this some content, it doesn't come from a single service. It comes from multiple microservices. And these microservices in our federation land, we call them subgraphs. And we have something that it's called federation. We have something it's called composition. Composition is an algorithm that takes the descriptions of microservices, meshes them together, and creates what we call the supergraph, which is a description that describes how you could get data with a query language called GraphQL from all your microservices. So instead of the website sending 100 requests to all these microservices, it's sending a single request to something we call the router, which routes the query to the subgraph. So it sends this query to the router. The router then figures out how to load the data from all the subgraphs. And then it makes a bunch of requests to the subgraphs, fetches the data, and gives you the response. This is cool for the front-end engineers because they don't need to know about 100 microservices. They just know about the description of this supergraph. The problem is, when you send this query the first time, a simple query takes nanoseconds to figure out how to get the data because we make one single fetch. But maybe you have like 100 microservices and your schema is a little bit more complex. There can be like abstract types and variations of complexity. And it can take a couple of seconds to figure out how to get you the data for the query. Now, a typical website doesn't have one single query. It can actually have 100, 500, 1,000 queries. So we have customers with up to 1,000 queries in production or even more. So that means you get a lot of traffic. You spin up new routers to handle the traffic because you have auto scaling and all these cool things. And now you have this router and it doesn't know about this query and it needs to plan this query. So there's a mechanism to speed this up because you definitely don't want to create a query plan for the same query twice. That would be very expensive. I mean, it takes a couple seconds, worst time. So we have something, we call it a query plan cache. So we get the query, we have a very complicated process to create a hash for the query. And this hash, it's our key in a map from this hash to query plan. Then we generate the query plan. It can take, like worst case, we have one scenario where it takes 10 seconds. And then we store this. And the next time the request hits this router, it comes from the cache. So we save 10 seconds. Now there's a little problem. Let's say you get this spike in traffic and you start the router. That means the cache is empty. So in reality, you're scaling up your infrastructure, and then this new router, it gets hammered with requests, and it takes more than 10 seconds to plan this query. This means the customer has to wait 10 seconds. So they after clicking this ad, it costs you so much money. You might not like the product because it's so slow. Which means before we actually take the router live, we should warm up the cache. So we should somehow have a mechanism to fill the cache without the customer waiting for the request to come to the router. So how can we do it? We built something for this. It's called Cache Warmer. And what we do is every day we look into the analytics data of the last 30 days, and we calculate a top N list of queries of how long it took the router to plan. So at the top of the list, there will be this query with the 10 seconds, and then there's a query with 9 seconds, and then there's a whole bunch of queries with like maybe 50 milliseconds or something, and then there's queries in the nanoseconds. Okay, so you create this list, we put it on a CDN, and now what we do is when the router starts up, we load this list from the CDN, we pre-compute the query plans, we put them into the cache, and then we take the router live, which means it takes a little bit longer until we can get this router live. But at the same time, the router is immediately capable of serving queries from the query planning cache. So all we do is execute. So there's no additional latency. And you might be thinking, okay, sounds very smart, cool solution, but why the heck does it take 10 seconds to plan? And the reality is, you can create like your subgraph or your supergraph composition in any possible level of complexity, and it's a simple function of mathematics that if you have a very small query and a small schema, it takes nanoseconds. And as you grow over time and you create like crazy complex queries, it can take a few seconds. And it is, I would say, there was a company who initially started to create GraphQL Federation, and they added a bunch of directives that do very cool things, like provides directive and external directive. And there's also very cool concepts like interface objects, and I'm not even able to explain them in detail. And all these directives together, someone has invented them. And at the time where they invented them, they thought it solves a problem. It solves a problem, like not diminishing that. But as you scale your graph, you can run into situations where it's very, very hard for a query planner to figure out how can I load this particular field? Because it might be in one graph, it might be in another graph, but actually here's an abstract type and it could be in 20 graphs. And so you have to compute every possible way this field could be loaded. And the unfortunate reality is this computation, it's a CPU bound task. We cannot just like speed it up in some magical way. We need to compute that. And then this is a limitation of federation. And the solution to this problem is, if you know ahead of time that you have a very complex query on your landing page, then you should have something like a cache warmer. And we also have a process with persistent operations, where when you deploy your front-end application, you can actually register all operations. So you can tell our backend, hey, I'm building an app and it has this query, it needs to be warmed up. So you can tell us ahead of time, and then you will never have a customer waiting for that query.
First of all, I think that explanation was absolutely brilliant. And one of the coolest things that I absolutely love about, working with such technical folks like yourself and building this company is that we get to see deep into consumer-facing applications, and we get to see what actually happens behind the scenes. And let's abstract a little bit away from the tech. From the business side, what is the impact of slow performance on the company. So for example, they launched this ad on the Super Bowl, and if you guys remember, Jens, you might not remember this, but Coinbase, they did an ad with just a floating QR code, and that was the entire ad, and a bunch of people scanned it, and so many people at the Super Bowl scanned it that they crashed the website. Let's say the website doesn't crash, but it's slow. Like, what are the business impacts of slow performance times that the pre-warming cache offers for like the business impact?
I think I don't have to teach business people that, especially if you're in areas like e-commerce or something, like every second counts in terms of people abandoning the website or something. So latency or high latency means you lose sales. As simple as that. You lose customer conversion. So it's super important. And that's, sorry to drift back to the technical side, but I want to emphasize on one thing, because I keep seeing discussions around REST versus GraphQL and REST versus Federation and other things. And well, one thing that is, I think it's very important to talk about, because sometimes I hear people say like, yeah, but we can do it with REST and it will be faster and so on and so forth. The reality is, and this is like, it took me very, very long to kind of conclude this, but if you have a website that does what we just described and it's using REST APIs, it is very likely that you are not fully aware what kind of REST API calls this website does until it's fully functional. Versus you have a federated GraphQL query and you're now complaining about like, hey Jens, why does it take 10 seconds to plan? And the thing is, with federation, we are fully aware of the complexity to load this page and the computation to load the data from all these subgraphs, from all the microservices. This computation, it happens when we start up the router, when we warm up the cache, we compute this once, and then we have a description of how do we get the data for this page. Versus if you have a REST API, the front end starts up and it starts firing all these REST API calls. So with a REST API approach, this whole computation of getting all the data to make the website work, it's the federation in the sense, it's happening in the browser and it's happening at runtime when the user waits. And now the question is like, you have latency between the front end and all your microservices. And this means going back and forth between the front end and all those microservices. It's much slower than doing it on the back end. So now you could say, okay, Jens, let's solve this problem with REST. We move this computation, we move it into the backend. We create a backend for front end, which creates a single REST API that federates the data from my microservices. You can do this. Now you make a single REST API call to this BFF. Now you have a new problem. The BFF essentially means every time you need a new query in the front end, someone has to build and deploy the BFF that now needs to fetch more or less data or whatever. Versus in a federated graph, you have all these teams building microservices. They contribute to the federated graph, and you have the front end team. They write their query. So actually, they work like fully independent. Versus with REST, either you have the federation in the front end, or you have it in the back end with the BFF. But now the BFF is like your bottleneck, because you have a BFF is nothing else but a self-built single use case federation approach. And actually what we have figured out is the limiting factor is not so much the tech. And the reason why many companies use federation is not a technical reason, it's an organizational reason, because you can have the BFF approach or the federation approach, but people prefer the federation approach because it gives them more flexibility on the front-end team, on the back-end team, because you don't have to constantly update this BFF. I hope it makes sense.
It makes sense. And you said something super interesting. So yesterday, if you remember, we were on a call with the customer and you asked them like, okay, how many people, like the platform team, like how many people are using Federation? And it was one team. And you just said that Federation solves an organizational issue. Can you expand a little bit upon that? Like, what problems does it solve? Where do you see Federation where it's the top tier solution? And why does it solve an organizational issue?
Think about the use case. We're a product owner and we want to bring new functionality onto our SuperBowl landing page. So let's say you have some existing functionality, you want to expand it. So you say, okay, we need, I don't know, I keep using this stupid example. You have a user and you want to show the avatar of the user when they log in. Okay, currently our API doesn't give us the avatar. So you're the product owner, you sit together with the front end guy and the designer, and you're thinking about, okay, how do we get the avatar? First problem, you have this big microservice architecture. You don't even know where the user comes from. This is not a technical issue. The first issue you encounter is, who is responsible for providing me the user data? So you could look at, let's say you're in REST API land. You look at the REST API call that you're making, and then somehow you need to figure out where is this REST API coming from? What are the people behind it? And oftentimes what we hear is the front end guy goes to the platform team asking them, hey, can you figure me out where this API is coming from? Who's building it? I need to talk to the people. I have a requirement. Versus in a federated graph, you look at the schema, you see, okay, here's the user entity. You can look what subgraphs is this coming from. So you know, okay, it's subgraph user. You know in which team the user subgraph resides. So you know who to talk to. And the next thing is, if you have like a REST API landscape and someone changes the user type, adds the avatar, maybe it's possible that another team has a similar user type and they use it in a similar way. And they might have a word with you on adding this avatar because they also want to have the avatar, but they don't just want the avatar. They also want to be able to compute the avatar size in terms of like pixels or something because they have a feature for that. So ideally, you would know who are all the people in your organization who are stakeholders on this user entity. Maybe you can talk with them and discuss this change. And this is something we have seen a lot with REST APIs, that there's like, I don't know, 20 APIs that do something with user, and everybody, like if they are unhappy with another API, what they do is they just add one more, wrap the previous user API and add whatever they want. And that's their API, because there's no like real collaborative schema design. Versus with Federation, you can actually say, okay, we have this entity, we talk with these other teams, and yeah, we believe enabling teams to collaborate on schema design, it's a big enabler to help you have a better, more concise API that really makes sense to the front end teams.
That's so interesting. So allow me to abstract a little bit. Let's say that I sign up for a very large organization. I'm a junior developer, and I was given a ticket that I need to go change the user avatar. And we have a REST landscape. So are you telling me that I would have to go and ask the platform team, hey, who implemented this portion of the user entity, and are other teams using it? Like I would physically have to go and talk to it. I wouldn't be able to figure it out from the code.
It really depends. Like there are things like Backstage, where you have like a tool that really has an open API spec for every subsystem that exists, and you can figure out who are the people behind. But yeah, we have seen that very few companies actually use like a registry or thing of that sort. With GraphQL Federation, you have a schema. It's not optional. Like OpenAPI, you can have it. GraphQL, you must have a schema, otherwise it doesn't work. And so in a federated graph, you must have a schema registry. So that means you must have subgraphs. Each subgraph has a schema, and if you have a schema registry like Cosmo, you also can associate people and teams with that subgraph. So if you look at a schema, you can immediately figure out who are the people behind it. You can talk to them. It's very transparent, and it takes very, very low effort to figure out these things.
And for the non-technical audience, a schema is just simply like a blueprint of that service. And so basically what you're saying is, let's say that this REST landscape, we might use something like Backstage, but it's optional. We might not do it. Maybe we're growing so fast, so we might not do it. But with GraphQL Federation, you cannot have it without a schema, which is a blueprint of how that service works. And with GraphQL Federation, it enforces that strictness. So theoretically, in a GraphQL Federation landscape, I have a visual graph of how the company kind of works in a more or less sense. And so I can go and I can make changes, and I can also kind of tangibly see what services are interacting with others by just simply looking at the schema. Would you say that's correct?
Yeah, very much. And it's also interesting. What's the name again?
It's the
this
law,
law.
right? Yeah, Moore's law, I think.
No, that's about growth of CPUs. I forgot the name. It's not Hiram's law, but there's a law. Maybe the audience knows. There's a law. It's not really a law, but the
Conway's law.
Conway's law.
Yeah.
So good. Conway's law. So the architecture that software engineers built, it kind of replicates the communication paths of the organization. So if you have 3 teams in your organization, it's very possible that you have 3 subgraphs in your federated graph, which is a pretty good feature, because if you happen to be a front-end dev and you use an entity on the user service, all you need to do is figure out who are the people behind the user service, and it's kind of like the subgraph architecture you have. It's somehow like, sometimes a team has more than one service, but somehow the subgraph architecture, it also kind of reflects the team structure of the company. So it's a pretty cool feature. And just a question, Stefan. So I know you used to be a developer in the past. Have you ever created the REST API?
I did, yeah, from the beginning. Yeah, and I had to like.
Did it have an open API spec?
I don't believe so. Yeah.
Most APIs in the world are REST APIs without the spec. And there's also, there's this debate that, I really like the ideas behind hypermedia. Hypermedia APIs are pretty cool, kind of like self-describing. You go to the API, it tells you like, hey, here's some information, and if you want some other information, here's some links, and you can follow them, and it's super cool. I just think it's not really for humans. I think humans, they are much better off with a spec. However, I actually believe that that there will be like a new summer for hypermedia APIs in the age of agents, because for humans to collaborate, it's better you have an open API spec or a GraphQL schema. For LLM agents, it's super cool. You give them a thing like a user profile, and you give them a link and say, if you want to have the comments, here's the links to download the comments. This is absolutely perfect for an LLM agent, because it can just then follow. And if you ask the agent, hey, can you give me information about Stefan and all the posts he ever did? So you go to Stefan's website, you get the posts, and then it gives you a link to you get the info about Stefan. It gives you a link about his posts, and then you can download that. So yeah, I think hypermedia, it will be very interesting to see the effects of agents on hypermedia.
Yeah, and I think it's super exciting. And I mean, just the description you kind of gave us with REST, with GraphQL Federation, I think is fantastic. With that though, I did want to jump back real quick to a CEO's point of view. So we have an amazing customer. They're preparing for a Super Bowl commercial, their first one, and it's going to be absolutely massive. They have a federated architecture. Cosmos kind of is crucial to them, which is why we've been working so closely for this preparation. But talk to me, like, what's going on through your head as you prepare our startup for an amazing opportunity? What are we going to be doing with this customer? The war room, if you remember, what kind of preparations are we taking in place to prepare for this event? And what can people expect will come post, not mortem, but like after? What will happen? Will we write a blog post about it? Will we describe it? Talk to me about how you're preparing for our Super Bowl event as well.
Yeah. So we're planning to have a war room to support them during the event. But actually, I'm thinking of this war room more like observing, because I think all the work, it needs to be done ahead of time. If we have to do something in the war room, it's simply too late. So all the load testing, everything, it happens ahead of time. We're in very close contact with them now, and yeah, we're working super hard together to prepare everything, to make sure cache warming behaves the way we want. So far, results are looking very good, and yeah, obviously for us, it's a huge opportunity to show the scalability of our platform. So we hope that later on we can talk about the event and outcomes and everything with permission of the customer. And yeah, but honestly, I'm not so much afraid of the event, because really I would say the bulk of the work, it's in the last year. Like, you kind of know if your software is working or not, and you kind of build this level of confidence. And I would say, like in German honesty, in the very early days of Cosmo, there were simply situations where we kind of knew there's queries we cannot really plan, or even worse, there are situations where we do not fully understand how federation works. This was like very early days, like over a year ago. And over the last year, we have like specialists working on composition and query planning, and they have built so much knowledge and so many, I would say, safe gates into our composition and query planning, and we really have built up confidence. Just to give you an idea, internally we have a database of all customer queries, all schemas, and whenever we change something like composition or something like that, we have like a very rigorous process where we run through all possible combinations of schemas and queries, and we check, are the query plans changing, is the behavior changing, and then we verify all of that. Yeah, you see, like, reliability, it's a big topic for us, but it can only come from having enough use cases. Unfortunately, there's not yet like a full specification for what federation is. So the best, or the closest you can get to a federation specification is to have as many customers as possible, take all the use cases and observations, and yeah, I would say there's actually, I mentioned earlier, there's something, it's called Hiram's law. And Hiram's law kind of says that the specification of a software, it's not really just the API specifications, but all observable behaviors from a software are the specification of the software. So for example, if you have a software that's super inefficient and it creates a lot of heat on your CPU, it's possible that someone in Siberia is using your software to heat the room. And if you now make the software faster, it means the CPU won't heat up that much, so they might now freeze. So you didn't change the API, you made it faster, but by making it so much faster, you changed one of the outcomes, one of the behaviors of the software. So you need to be careful. You can't just make something too fast. Maybe make it slightly faster or something. So I mean, this is a ridiculous example, but coming back to federation, federation is such a complex beast. I would say there's not a single company that knows federation from or understands it from A to Z. And as such, it's very important to have things like benchmarks and audits and collaboration between vendors to kind of conclude what is the agreement that the majority of people find in how federation should work. And on our end, it means we have a lot of customers. We have their schemas, we have their queries, we know what kind of outcome we want when we run a query. So we have all of that in a huge internal database, and every time we change the behavior, we check against that, and that's really helping us to improve it but not break it. And now you know a little bit about our life here.
Yeah, well said. So we are nearing the hour, but we do still have two more topics I want to discuss. So I want to talk a little bit about the conversation that we had with that crazy large customer that has a first world tech problem. But before we go into that one, let's talk a little bit about descriptions in Federation, since we're in Federation land right now. So this was a topic that came up this week, and I know you have some thoughts on it, but what are descriptions in Federation? Why are they important? And what are your thoughts on them?
Okay. Problem very simple. So every node in a GraphQL schema, you can, or I think most, you can put a description on the node. It means you have a field. The field allows you to query user info, and you can put a description to say, like, what is the purpose of this field? And this is very important. Like I mentioned earlier, you need specifications for users, and code is not self-documenting. You need to document why this field exists, what is the use case, and what is important about that. Now you have a little problem in Federation that we figured out. It came through one of our biggest customers. You have one team, they create an entity, they add a field on the entity, they put a very thorough description on the field to tell everybody else in the company what's the purpose of the field. Amazing. Perfect. That's the way we want to have it. Well documented APIs. Awesome. So we ship this into production. Then a while later, second team comes along, says, oh, that's an awesome entity. We add something. So they create a subgraph. They put something on top, and they are like, you know what? I want to have your field. I can use it as an input because I want to compute something with your field. So they use the provides directive and add this other field. They cannot resolve it, so they put external on it. So now we have a second graph that has this field. By the way, same problem with shareable. And essentially you have two graphs. They have the same field. And now both put a description on it. One team put a description on it to tell the rest of the company what's the point of this field. The second team puts a description on the field because they want to have some internal information telling the rest of the internal team why they have this field and it's external and blah, blah, blah. So the purpose of a description in a schema can be to communicate something to the rest of the company, or it can be to communicate something to the team. In both cases, your tool of choice is the description, and there's no two descriptions. There's no internal or external description, all these kind of things. You don't have that. So now you have a little bit of a race between because whoever comes first they push their description, or there's algorithms in other federation solution that pick the longer description. Or like, what description should we choose for our federated graph and for the subgraph? Like, what's the right description? And so we were thinking about this problem, started an RFC process, how we do this quite often. And we are getting close to a conclusion. And somehow we think the right way is we introduce a new directive. This directive allows us to say the description we have on this node, it's public, yes or no. So if it's not public, it will not go into the supergraph. We want to keep that to ourselves. If it's public, it goes into the supergraph. And if a second team tries to bring in a description on the same field, also make it public, we will have a composition error. So in this case, we now have composition to prevent this error from happening and not randomly choosing one description. And then there's a second thing. We can now put a description on the field, and we can have on this description configuration directive, we can have a second field where we can define like a custom description. And this custom description, we can then publish that into the supergraph. So this allows us to have a private description for the subgraph team, a public description for the supergraph, and we can decide do we want to have it private or public. And if that's still not enough, we can even have a custom one.
Very interesting. And so with maybe for like the non-technical folks, this issue with the descriptions, what's happening on the business impact? Are developers stepping over each other? Is it slowing down development? On the business side, what is the problem that this is happening, not related to the tech side? Does that make sense?
I think, so I would say for the different stakeholders in your company, it's super important to have, first of all, to have documentation on what the API does, how it works. And sometimes you simply want to keep information within the team. And from our point of view, coming back to our thought from earlier, federation, it's a collaboration tool. It allows teams to work together on an API. Documentation, good documentation, it's paramount to achieve that. It's the most important thing. So being able to have external and internal documentation on the field, it's very important, because otherwise people cannot work together. You want to know what's the purpose of the field, and you want to explain to others how to use it. So I mean, that's
No, well said. And so we are at time. So what I do want to say are a little bit of closing notes. So as discussed in the beginning, WunderGraph is hiring. We're hiring for engineers. We're hiring on the marketing side, and there's going to be a lot more job postings coming soon. Benefits of working at WunderGraph: you get to work on some amazing technology. You get quarterly retreats, competitive compensation, choose your equipment. And quite honestly, it's such a fun place to work. As we did that like scale on the retreat, the biggest things our employees loved was how close they are to the customer and the impact that they're making. So WunderGraph is hiring. You can find it under our jobs link. Quickly apply. And if there is a job that isn't there, but you think would be a great addition to WunderGraph, some skills that you have, you're like, you know what, I think I can bring this impact to WunderGraph, just email us directly. Mine is Stefan at WunderGraph.com, and this is Jens at WunderGraph.com. From that, pre-warming cash, setting up for the SuperBowl is going to be amazing. Super excited for that. But other than that, Jens, any closing words, any exciting things, anything that we should mention before we end episode 2?
Do you know what the good thing is?
What is the good thing?
We're back in a week.
This is true. We are back next week, 9 a.m. Eastern time and 3 p.m. Central European time.
Not next week. We're back in 2 weeks, actually.
Oh yeah, Jens is off next week. But I think I'm going to do an episode next week with Dustin or Bjorn, one of the other co-founders, and I'll just chat with them. Could be fun. But you're going mono skiing, right? Oh, look who decided to show up. It's our good friend, Mark. I hope, Mark, you were here the whole time to hear our discussion on federation. We went quite deep on the topic. But awesome. Jens, as always, it's a pleasure to do this with you. Thank you guys and everybody that joined us. Please apply if you're looking for a great job to work on some interesting technology. And I will see you next week, and you'll see Jens back in 2 weeks. Thanks, guys.